Good evening, Professor and the whole class. My name is Imrul Kayes, and today I'm going to present semantically enhanced UAVs to increase the real scene understanding. So let's begin. So today my presentation plans include these topics. I will first introduce the background of the topic, and then I will be talking a little bit about ad hoc networks and their current uses, and then I will go to the part of research questions of why the authors conducted this research, and I will be talking a little bit about the methodologies and experiment as well. And after doing the experiment, what they were analyzed, and then finally I will conclude this presentation and share my opinion, and I will show the sources from where I have prepared this presentation. So we all know automation is growing, is becoming very important these days. And the human-made things are turning to be automated things as well. We have seen Google created a car which doesn't need to have any human to operate, and we have been already introduced with the ad hoc networks such as flying ad hoc networks, and we have seen drones which are totally self-operated in some context, although we know drones have to be controlled by human beings, but the UAVs, unmanned aerial vehicles, are not controlled. Actually, you send them, you put the instructions in the code, and they are operated as instructed previously. So they are self-operated. They can record videos and in many real-life applications such as monitoring and surveillance app, and they're also used in real-time video tracking. So the purpose of our research is, of this study, of this presentation, is to track the videos which are recorded in different scenarios and to make a decision. So why are we doing this research? Previously, this type of studies have been done, but in Web 2.0, there is a web of document where the machines don't understand the data; they just transfer the data, and people can be a little bit interactive through those data, but the machines cannot take significant decisions based on those data. But in Web 3.0, which we are calling semantic web, the approach is for the machine to understand the data as well, while they are also interactive. They can understand the data, and based on those data, they can take decisions as well. So the ad hoc networks contains MANET, VANET, and FANET, which are actually mobile ad hoc networks, vehicle ad hoc networks, and flying ad hoc networks, sensor networks, etc. So our videos will be recorded by a drone, which is a flying ad hoc networks. And after that, we're trying to analyze those videos and make important decisions. So what are the resources? We'll be seeing a little bit what are the resources those have been done previously in this field, and what are the resources to be explored in the next days. We have seen in different studies showed that single objects have been classified very accurately, while the picture is taken from a still camera. But what about the background information? What about the moving cameras? If the camera is moved along with the object as well, what happens that time? That time is it possible for us to predict the object very accurately and get details about that object? What about the tracks? What about the background that was beside of that object? Because the behavior of the object and the whole scenario can be changed if the background changes in some context. So we will be talking a little bit about those as well. And what about the environment? Is it possible to have a better understanding of the environment rather just detecting the single objects? And what are we going to do to support the decision-making tasks? So this research has proposed a totally brand new framework, which will try to answer those questions as well and try to solve some of the issues I have mentioned. So the high-level scheme of the framework, we have divided the framework into separate parts, while each parts act differently and they have individual tasks to do. So there are some modules called tracking modules. So we all know the tracking modules can track an object and get details information of the object to some extent. And then we have the POI semantic mapping, what is point of interest semantic mapping, which we are calling the reference points. In terms of the reference points, we are gonna see the movement of the object, and we are gonna make decision about the objects. And then we have relationship semantic mapper. We have collecting module, we have inference module as well, where most of the semantic tasks will be done regarding the decision-making process we will see. So from the image, we can see clearly that the tracking module is trying to track a car. So while it is tracking the car, it is getting the dimension of the car and getting the speed of the car and how far the car is from the camera. It is also detecting that as well. And about the background scenario, what is it doing? So we are filming that car from a drone. So drone has a GPS coordinator. So it is totally linked with the internet, linked with the Google map through the internet. And from the Google map, it is using the location and trying to examine the surroundings. What are the surroundings of that car? So it is getting the background information as well. And then it is passing the information to the semantic mapping. So after passing the information, the semantic mapping is getting the track and position and the vehicle information, and it is scaling the data to the point of interest to the background, and then sending the data to the collecting module. So after the collecting module taking all those informations, it is sending those all informations to the inference module through asserted knowledge scheme. And so after inference module taking those information, it is analyzing those information clearly and trying to make decisions based on the data gathered from all of the other modules. So before moving to semantic web, ontology is a part of semantic web. It's an ontology scheme, which actually a way to describe a domain of interest. The domain of same interest lies in the same place. So the figure shows on the track point of interest ontology schema. So where we can see that there are two main classes, which are track and point of interest. So track class has also two subclasses, vehicle and person, and the other subclasses of vehicle is car and truck. The person subclasses can be adult or child, and the point of interest subclasses are highway, park, parking lot, and route. We can see the point of interests are always fixed, while the track subclasses can be different in different scenarios. So what are the methods by following which we are conducting these experiments? We have used different functions to describe the data differently that will help us to make the decisions. So track POI, the function has relation with, the another function is in the area of. Similarly, is near, has direction, is in front of, is behind, is in between. And from the image, we can see as well, from number A, we can see X is in the area of Y. And if we say in the example D, so X is in front of Y. So while we're telling that X is in front of Y, so which means that Y is also in front of X, because X and Y will be in front of each other when they are moving to each other. So let's move to the next page, class restrictions. So how the classes are restricted. So from here, we can see that the person class is defined with the description of the person, such as height, has speed, has width. So if the height, speed, and width is in between a range, that time we can see that it is definitely a human being. And some other restricted classes, for example, if a park, inside a park, only person or humans are allowed, or pets are allowed, no vehicles are allowed. How we're going to define that? So we are going to tell that POI and objects allowed only person, or objects allowed only pet. So the experiment has been conducted on full recorded videos. The experiment we have done in this study. So the data sets were 10 recorded videos. The authors recorded those videos with DJI F450 drone and DJI Namjam version 2 control unit. They have used also Nilox F60 camera with 128p full HD resolution and 175-degree wide view angle. So why actually the authors recorded those videos while there are thousands of videos in the internet? So they have told that they tried to show a real critical situation where the framework, they can see the performance of the framework, whether that is working properly or not. So the experimental data, we have taken some screenshots from those videos. From the screenshot A, we can see that two persons are moving toward the road, walking towards the road. In picture B, we can see one person is trying to cross the road while the other person is staying away from him. In picture C, we can see that a person is crossing the road coming towards other person while the car has already passed him. In picture D, we can see some shadows. So our analysis, when we are tracking all those objects, those moving persons and the moving vehicles together with a moving camera as well. So how can we keep track and make difference? So we have some functions, infrared triplets for track 2111395. So track 2111395 is the person crossing the road, and the vehicle has another track number, the other person has another track number. We can see from row second and third, and at the very end, those are in red color because the person is in danger. So the framework, the algorithm of the framework can consider the person and vehicle, and they can track speed of the vehicle and can decide that the person is in danger while the vehicle is coming towards him at a higher speed. So is the tested data, those are correct? So they have tried to see a F1 score with precision and recall. So from the F1 scores, for all of the videos, it was seen that the scores are pretty accurate, except the score in video 1, number 4 scenario, where recall has turned out to be 0.44. It is less. In the other, all of the other examples, the score is pretty high and it's almost accurate. So what was in video 1 Number 4, it was shadows which the algorithm couldn't detect those as a person. So one similar example is two people are trying to move around at the center of the helipad. While they are at the center of the helipad, definitely this algorithm can detect them as dangerously situated there. While they are at the border of those helipad, that time they are safe, and the algorithm can detect through semantic web technologies. So how it can understand the situation? Again, it scales the scenario in different scenario, and it tries to matches the different scenario like supervised learning. So event 1, we can consider event 1 as walking or standing around the route or heliport. Event 2, walking or standing near the route or heliport. Walking, crossing or running the road when it is empty. Crossing or running the road when a vehicle is coming. So this is definitely dangerous. So similarly, we can see some other events as well. So what is the equation about on the right side? So A is the accuracy of the events, and S is a specific scenario, specific scene, and E is the number of total events. So this is how we can see the accuracy of those events as well. So to conclude, this is a great process related to other studies to enhance the video tracking task by adding semantic information. It is possible to high-level compensation description, to get high-level compensation description. It's possible to get high-level descriptions from the video we are trying to analyze, and it is very easy to identify the object and understand a situation by the help of semantic web technologies, and with the help of moving camera and speed detector, it is possible to determine the speed pretty much accurately. We have seen from the F1 experiment. But being said all this, there are still a lot of research to do on the field of semantic web technologies, so that it makes our life more easier. So in my opinion, more improvements definitely can be done. Well, considering the object speed is very high, or there are maybe thousands of objects, the time the algorithms will struggle to detect all of those objects. And in this experiment, we have depended on GPS system to get information about the surroundings, but we know that when the internet connection is slower, or there will be some place where there will be no internet connection at that time, the GPS will not always show the accurate result, or cannot show the result at all. Sometimes that time we will struggle. So I think in the future there will be more studies to solve this issue. And for every incidence, the danger level is not same. So I think for those events, danger level is very high. There is a alarming. There should be alarming level, which will tell about the danger level as well. That will make our lives easier and safe. So this is all today. We will talk about later, maybe in future someday. So these are the primary source I have used to prepare this presentation, and these are the secondary sources I have also used to prepare this presentation slides. So if you guys have any question, you can feel free to ask me at the discussion board, or maybe email me. I will try my best to answer them. Thank you for today. See you in the class.